Okay, so last one of the day, and then you can relax a little bit, or at least get out the heat. Dinko Cudic is from ICorr, and Dinko is going to talk to us about why paint when you can patch. Dinko is the business line director at Seal for Life Industries and has spent over 2 decades in the field of corrosion protection. Started as a site supervisor on pipe lay, structured steel and above ground storage tank construction. Most of the experience has been in the field, both rehabilitation and new construction. The last decade he has spent time to seek new technologies and solutions which focus on increasing lifetime of the asset through workmanship, equipment and innovative coatings. So Dinko, over to you.
Thank you. Yes. Yeah, most of it, even the new build, I have to say, was always out in the field. The rain, the sun, the cold temperatures and so on, and trying to face all the challenges of how to work with these. So seeking these new technologies was mainly, we have a lot of technologies out there where we need to accommodate a lot of things to make those technologies work, educate the people and so on, or even change the climate and the environment if necessary. Or do we look for technologies and develop technologies that will more accommodate to the actual environments that we work with, but also the people that we work with. In some countries of the world we have education, what is blasting, what is painting and all those things, but there are others around the world where we get people off the streets, mainly they hang out in front of the gates, and we make them into blasters and painters within a week or so and do major projects with them. So that's the reality. So that's sometimes also something that we need to consider when we choose our coatings or develop coatings. So I'll talk about patching. So this is a repair, a coating repair solution that we have developed, and I will focus on the wind industry here, even though it's applicable in other areas. But it's also how to patch and repair for long term. And that, of course, goes in line with the previous presentation where we want to achieve the asset lifetime of 40, 50 or 60 years, even when we damage it during the installation, during rigging of the equipment up the windmills and the equipment knocking all over the windmill and creating corrosion spots. Somebody needs to go back there and repair them. And then, you know, we fall into also the things that we always come up with new names and circularities and so on. And circularity is a great word, but how big is your circle is also the question. Are we talking about 5 years, 10 years, 20 years, or 50 years lifetime? That's what we need to know, and that's something that, you know, I'll try to show. Wind farms, yeah, brief introduction. All over the place, they're popping up all over the world, and you know, we saw earlier, independency also goes with this, where we are able to make not only certain countries a little more independent to energy sources, but also we can develop certain regions of the world that haven't been developed because there was no electricity. And now using solar and wind, we're actually able to bring and develop certain areas, which may even depopulize, you know, highly areas with high population. So we have different structures. Different structures offshore mean different problems, different issues, different installation constraints, and mostly what we focus on, damage. How much damage to install each and every one of these. We have seen also floating is picking up. Floating is something that some countries also would like to see as float it out, use it when they need to maintain it, float it back in, maintain it, float it back out, so something more movable than, let's say, piling things in and then ripping it all out as, you know, capacities evolve or so on. Construction constraints, and these are big things. Historically, we come from coating of pipelines, and surely if we look at this, it's just a big pipe. But of course, they are very thick pipes, very heavy pipes, so you have to face weight issues and other things that you know, will coincide with these things. So even for us, coming from the pipeline coating industry, we had to take certain things into account. But of course, like I said, here we will focus purely on repairs of the coatings, but also standards. How do we know if it works, and how do we test innovation according to standards. Innovation is generally not a standard coating, but we have to test it according to standards. Now, just to go through what it usually takes to coat something, we have to go through the whole blasting process, surface preparation, and we know how important it is. It depends on what organization you look at, but you will hear terms like anywhere from 70 to 85% dependency on the coating quality, or the 30 or 40 years, that dependency on how well was the surface prepared and how well did we apply it, and in what conditions, of course. And that's something that we need to look into. Nowadays, we are also a lot more conscious about waste management. We bring in grit, abrasives, and so on. We create dust. We use a lot of energy to prepare the surface. Once we coat the structures, what do we do with all those cans, the cleanings, all those VOC-containing materials, the thinners? We can't just dump them like we used to many years ago. So, those are all the things that we need to take into account. And these CO2 emissions, depending on the country, let's say in the Netherlands, where I lived for the last 6 years, there's a limit. And if you reach that limit, you can't do anything more. So if you use up that limit on surface preparation, or waste management, or the coating part, which part you use it up, sorry, you can make only 100 piles, and come October, you're free to go home. So, also something to consider. Offshore wind farms, this is where a lot of the damage happens. The movement of all these piles, loading it onto the barges, offloading it, installing it, scratch here, hit here, cherry pickers that go around these things, that's where you get a lot of these, even before it all becomes operational. So we'll talk about the damages. Like I said, a lot of them come from hoisting, installation, transport, at site, and then we have to repair it, limited access to a lot of these areas. When we do maintenance on offshore platforms in the oil and gas industry, we've got accommodation blocks, we've got toilets, we've got a restaurant, we've got all these things. When we go onto these individual monopiles, where do we do this? And we have all these vessels. So we have a few hours to get on, do our job, and then go out. And all these rope access guys that are hanging out there, they actually take lunches up there and so on, because they can't be bothered to go up and down. And then when you have certain systems where you have to do surface preparation, first coat, drying time, second coat, drying time, third coat, drying time, and all that, how confident are you that it's going to be a quality job? And of course, we create waste. What do we do with the waste? There are companies now in the North Sea that do not want to see buckets of paint offshore, because they do not trust the applicators that they won't throw the buckets into the sea. So, people are looking, companies are looking for solutions, from waste management. And then, of course, the temperatures, the humidities, all these things that can affect the quality of the paint. So yes, maybe you spend 3 days repairing a little patch like this because of the overcoating times and so on, and then after 6 months, there it goes. The corrosion flowers again, and you have to do it all over again. So we decided to take one of the older technologies from Seal for Life, which comes from a brand called Stopak that was developed about 25 years ago. It's based on polyisobutene, which is a polymer that doesn't allow oxygen and water to go through, more with waterproofing and sealing, seal it off from the environment, that kind of approach. But of course, some of the benefits of these polymers are non-aging as well, but also environmentally friendly, people friendly. Environmentally friendly in the sense that nothing will leach into the environment, and maybe environmentally friendly because it doesn't have a lifetime, so it won't degrade, so it won't choke into the atmosphere. So you can always look at environmentally friendliness. Will it disintegrate within 5 years and then be part of the environment? Or maybe it won't, and then it will be exactly where you wanted it to be. So yeah, I'll skip this part. It has cold flow and it has certain benefits, so it can be applied to different areas. And purely, you can achieve a lot more, like minimum surface preparation, adhesion to smooth surfaces, like a coated surface, etc. And it comes from the adhesion mechanism. So the adhesion mechanism is a dispersive kind, most similar, let's say, to honey. You touch honey, you have immediate adhesion. You didn't force it, you didn't do anything with it. And whatever else you touch will be sticky. So that's, you know, kind of the adhesion, and we can utilize that. And of course, it's a polymer that is a free-flowing material. So actually, the only secret of these products is that polymer under control, so it stays exactly where we want it to stay in the environmental conditions that it's supposed to be, operating temperatures, etc. So this is what it looks like. We designed this product specifically for the wind industry, taking into consideration the applicators that need to do it. So it's a single coat system that has a release liner. You remove the release liner and you put it onto the surface. So therefore, we have it available in yellow and gray, for example, for the windmills. And this is how it functions. So you have a layer, which is your anti-corrosive layer, and an adhesive layer in one. And you have a backing that comes on top, which gives you UV resistance. And it's an ETFE, so it also gives you some self-cleaning properties and so on, so dust and rust won't accumulate and it won't not choke over time. Actually, recently we had a comment if it can choke over time because the rest of the coating is choking, so then you can clearly see every patch after a few years in service. So, but no, we'll keep it as good as we do. So that's more or less how it works. I explained that. But now we needed to test it because obviously you get a lot of requirements for testing. And we tested according to 12944 CX conditions for the offshore. That standard is not made for these kinds of coatings. It doesn't specify them anywhere. It's 3-layer coatings. So how do you create a coating that will accommodate to these things? So I'll just run you through it. Some things are great, some things are not good. But I will show you failures. So in a way, I'm also questioning this standard. And I'll show you reasons why this standard is also being questioned. Because you prepare carbon steel plates, you remove them. Now, like I said, because of the adhesion mechanism of this material, you can get away with minimum surface preparation. Remove loose rust, loose paint, and just put it on. So you don't need a roughness as such. And therefore, a lot of the tests that we do are on that minimum surface preparation. So rather than SA2.5 with roughness or without roughness, so if we just stick to the cleanliness method, but we try to do as much as possible because it is a repair coating on purely mechanically prepared surfaces. And of course, we take care that you pass all these requirements in the standards, so we do everything right. Prepare the patches, we've got them in, and then throw them into the lab. And then we go through the testing. So how is the pull-off test and so on? Again, it's not a coating. You're not going to get much force needed to get cohesive separation because the material stays in its tacky form over time. So when you get any value, it's a cohesive fracture value rather than an adhesive failure value. So these are the things you need to consider. But fine. So we go through, of course, all the exposure hours, etc., to do that and to bring it to a part, where we test that. And then, most importantly, corrosion and scribe, because corrosion and scribe is one of the things that many people are looking for. So here are the, am I at the tests? Yes. So here are the tests. These are the, oh, I can't, okay. That's my colleague, he likes these things. I'm not so used to them. So here are the tests, and here are the performance data. So you can see some differences when it comes to pull-off. That it doesn't look like much, and that's because of the nature of the material and of the product. But apart from that, all the other things, perfect coating. So how does it perform at scribe? Now back to the laboratory test. What are we looking for in a coating as well? And what we are looking for is, like I mentioned, we did it on a SD3 cleanliness, scribe made through the coating, mechanical damage, etc. And this is the ideal barrier. This is what we want to create. And what we are really looking for is deterioration over time, which can be seen through coating breakdown factors or however, which is how long does it take for the coating to become permeable to the environment. And as we've seen graphs, it's not a linear thing. It usually starts very slow, but when it really goes through, then you have an accelerated degradation with time. and then cathodic protection is there to take it over, or sometimes make it even worse. So that's the barrier function. And then you have a corrosion, and then you go in. So this is reality, for example, that we get. So we have been using this technology for, well, this is after 5 years. It's actually quite difficult to get information from the wind industry. Everybody's so secretive about it, like don't show this, don't show that. So this is what we managed to get after 5 years in service, just to show what it looks like in reality. And this is also shows you where you use it. So every one of these points was maybe a chip of paint, some sort of damage. You wire brush it, you patch it, and that's it. Blends in with the color. Sure, you can see the adhesive collected some dust over time, so maybe it doesn't look perfect, but at least it's protecting the surface and the corrosion is not spreading. So I'll go through this part, which is laboratory tests versus field experience, and mainly we're focusing on corrosion at scribe. So here we have found contradictory. So we know in reality it works, but then when we did the test in the laboratory, we have actually found penetration of water underneath and actually a complete disbondment of the system. So you can question, is the coating bad? But it did work in reality. And of course, our preference is that it works in reality rather than in the lab. So we thought, okay, so how do other coatings perform while they have passed the corrosion at scribe in reality? And this is what we see, because this is actually what we repair. So here is the kind of a paradox where a non-ISO certified coating is repairing ISO certified coatings. But you know, this is reality and this is what we see. Now, what happened here? Why did we get these failures? We know we passed the test. But we have to be aware that when we do the test, we put it on, you saw one of the plates, on a small plate. We didn't take into account the movement of the wind, of the whole tower. We don't know what the failures are on that tower over there, but you can see that almost every weld failed. Was the heat affected zone too big? Did the whole tower become too flexible or too rubbery? And that's why the coating popped up? We don't know. But that's where we also started to explore all these things, like why is this happening? So we have coatings that have passed the test and so on, and then we get this, and then we get the reverse. We fail the test, but in reality, we go back and repair all these with good results. 5 years doesn't seem like much, but we know that the technology has been around for about 25 years, so we know it has worked in other areas. We just redesigned it for this environment. So this shows you, roughly what we do. We go back here, and we'll look for these scribes, and then we repair them. Minimum surface preparation, because it's not easy. Again, if we want a very good job, we need abrasive blasting. How do we do abrasive blasting at 80 meters height? How many cubic feet per minute or volume of air do you need to push your abrasive all the way up and do all those things? It's not easy. Spray equipment, overspray, where is it going to go? All these things. So yeah, we have to rely. And how many tests do we do with the normal coatings on just picking with a hammer and so on? So these are examples of the repairs that we do. So minimum surface preparation, as you've seen in the slides before, remove loose rust, loose paint, feather the edges. If you can't feather them, we do have paste, so you can mold around it. If there's high pitting, again, paste just to make it all flush, and then patch it in. And that's what it looks like. But then, what I mentioned before, we also have to look at what are the effects of the jobs that we do. We have to be aware of that in comparison with, especially in the field. If we go to an offshore site and we have to coat 100 square meters or repair 100 square meters, it's not that big right now, but you'll see in 10 years, 15 years, 20 years of the lifetime of some of these windmills, we're going to have to go and do maybe 20 square meters or 50 square meters. How do we do that? How do we access it and so on? We have seen great innovation from the blade repairs, and I'm sure that there will be coating works over there as well. Chloride content, roughnesses, all these things, something to consider, and then again, waste. One of our clients that we work with from the North Sea, they started asking the questions, What is our favorite abrasive that we use? Garnet. Everybody loves garnet, doesn't dust too much, and so on. Where do we get garnet? From a beach in India. What have we done to the beach in India? We destroyed it. And then we carried all that weight to Norway. Then we did the blasting and painting. And then we dumped it where? In Norway. And then we had to filter it and all that so we can get the old coatings out, especially the ones that have chromates in it, that have lead in it, asbestos in it, and all those things, filter it out, and then dump it. What is the cost of all that? And why do we need to do that? And then, of course, how often do we need to do it? And that's the circularity question as well. Do we have to do it every 5 years, 10 years, or 20 years? So do we do that whole process every 5 to 10 years? That's the big question. And we have seen in oil and gas a lot of times that that's exactly how often we do it. Every 5 years, we just do the same thing over and over again. In rehab, I'm not talking about new build. But once you reach that rehab, with all that chloride content, with all that humidity in the air and so on, it doesn't become as easy as it was when we first made it. Because at least in the beginning, we could control the environment that we do our surface preparation and application in. And that gave us life. So yes, that will be all from me. So we still have time to refresh and cool down.
Excellent. Thank you. Any questions? Trevor, you know. I know, yeah. Yeah, go on. You talk about garnet, big garnet. I mean, that always makes me laugh. Because nobody lasts with big stuff. That's why we use garnet.
You might as well bring it from Australia. It's not that much further, but it is very expensive. But it is a very good material, and it's very, very low in chlorides. But equally, there's all sorts of other things you could use which are available in Europe, in the UK, either in the UK or in Europe. We blast all the fill joints on a project recently with a material which was from Russia, which was nickel slag, which was cheap as chips and did a fantastic job. So, I mean, there are different alternatives, and I would never, ever use Indian beach garnet. It's probably okay for some things, but certainly not for what we do.
Oh, it was an example.
Yeah, sure.
But let's say, whatever we take, there's a process to it, and we have to carry it around and recycle it. That's what I wanted to achieve. Now, initially, when I started this 25 years ago already, it was very popular to do things with water jetting. Unfortunately, water jetting didn't give us the roughness that we needed for the coatings, and that's why we stepped away again from water jetting, because we couldn't get the roughness. And yet, in all that time, how many technologies have we seen that would accommodate to that cleaner way of doing surface preparation? Instead, we just went back to the dirtier way of doing surface.
Water jetting originally, you were cleaning the material of a substrate that had already been blasted in the
Yeah.
process, so you weren't trying to create a profile.
Yeah, I mean the new build, if we wanted to new build. Yeah. 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 True.
Any other questions? Suman.
Yep. Thanks for the presentation. Quite thought-provoking and useful. You mentioned the ISO 12944 is not really designed for a product like this, and it's not designed for a maintenance situation either. We've been also thinking about, what laboratory test standards to use for in-service maintenance. Do you have anything that you would recommend as a test standard for your products or maintenance situations?
Well, yes. There is one standard that is made for this type of technology, but it's for buried and immersed pipelines, so more for those. But we would need to create almost a new standard. Now, when we approached 12944, just like we did 21809-3 for submerged conditions, yeah, we were not accepted to create our own chapter because, you know, we were told, no, this is for coatings and stay out of it, create your own standard. And that's a painstaking process, so we will do it eventually, but it will take some time. But meanwhile, we are able to use, with one of your colleagues from the US as well, a mix and match of standards where each one proves something, and then when we bring them together, that kind of gives us closest to the reality.
Okay, thanks.
One more? Anybody? Patrick, I'm coming.
The original Stopak technology was always for pipelines, right? And
Correct.
a lot of the adhesion is actual tension that you're wrapping a pipe. So you're getting you're not only relying on the sort of adhesive properties of the product, but you're also relying on the tension that you're applying when you're wrapping a pipeline. Now, in this case, you're only relying on the inherent adhesiveness of the material itself. Is there accelerated? Because you can't wait 20 years to see just how long it's going to last. So we've got some accelerated data to see this thing will actually stay on for 20 years. Like.
We actually do have real-time data now, 25 years later. No, Stopak does not rely on full wrap. Even if you put it on as a patch on a pipe, it works. The reason why we put outer wraps is to give tension on this liquid kind of product, which provokes self-healing effect and some other things, impact resistance and soil resistances. But no, the polymer and the way the adhesion works, you don't need a wrap around and you don't need anything to hold it back. You know, and it's beautiful to be in that liquid phase and so on. You get certain effects, just like water. Even though it's not water, it's not going to run down. And apart from these 5-year exposure samples, we have plenty more, just as a standalone on a flat surface. But you know, you get all these. So just like water, you get creep as well. So even if you put it at the 6 o'clock position of a pipe, you will see it crawl upwards because those are the effects of viscosity that you get. But no, we don't need to be wrapped around to hold it. Stopak is not a tape. No.
But grandfathered from?
Sorry?
But grandfathered from
Well, as
Stopak.
Yes,
Yeah.
as a technology, absolutely. Yes. So it is something that we know works, and the track records and everything. It's just, and we always had this idea: why can't coatings be applied like wallpaper? And the whole idea of these paintable versions is exactly that: apply coatings as wallpaper, self-adhesive ones.
Oh, one more then. One more question. 1 second.
Thank you very much. Is there a limitation with the size of the area that you can repair?
Not really, but
I mean, for big areas, how is the application?
well, the bigger the area, the more expensive it's going to
At the
get.
height.
It's not a cheap product.
All right.
No, there's no limitation. So, you know, with Stopak, we do millions of square meters annually of pipelines and so on. So that works. This is just a standing up pipeline, so it is workable, but no, there are no limitations to size, except financial ones.
Okay, thank you.
Okay. Good. Thank you very much, Dinko.
Thank you.